Okay, we've come a long way. We're in section 30 of the notes now. And I believe this is the last section. Let's just check. Yeah, it's the last section of the notes. And this section here is completely the review of what you did in Math 120. Some of the stuff I have down is optional, and that's the rotations, but that was extensively covered in Math 120. The reason rotations were covered in Math 120 is it's related to trigonometry, and we're basically just rotating through some acute angle counterclockwise of the conic sections. What are the conic sections? Well, I'm going to say circle, parabola, ellipse, hyperbola. There's also degenerate cases. Let's not worry about that too much until we see them. What does degenerate mean? They lose their characteristic. For a circle, you could write an equation of a circle down that's degenerate. And what would that mean? Well, it would look like an equation of a circle, but when you graph it, it would just be a single point. All right, that would be a degenerate circle. So the problem over here is what we're going to do is we're going to review it. It's going to be, basically just a review, and then we'll go through examples. There will be some homework for you to review, and there will be some assignments for you. All right. Also related Sage code for those students interested in taking a look at the Sage. So let me go to that section. I'll be covering this, and I'll do it at the whiteboard. As I go through it, I kind of start slow with what you first seen. The first conic section you see at Essex County College was actually a parabola, and that was done in Math 100. And I'll relate back to that. But again, we do need to move forward from 100, 119, 120. Of course, you guys are in 122, of course. This is a review of the old stuff. And I got to get to my whiteboard. And let me do that. Okay, you're seeing my my graph over here. And what is this graph of parabola? Certainly, it's like a Math 100 question. I'll put little arrows in over here indicating this goes on forever. All right. So what is the equation? The equation that we're graphing here, and it says it says the figure 124. The graph is a graph of y equals. It's a partial graph, by the way. You could never draw the full picture of this. So when you're in Math 100, most of your teachers would recommend to you that you factor the problem if it was factorable. If it's not factorable, they'd say move on. I think this is factorable. Let's write this down. And what do you get over here? Y equals x and x. I say 3 and 1, fairly simple. I'm going to say plus 3 minus 1. Does that work? Well, you get x squared. Plus 3 minus 1 is plus 2x, and you do get minus 3. Then what they said to do? They said write some points down, some key points. Certainly x-intercepts are key points. And what's that going to be? Well, when x is 1, y is 0. And when x is minus 3, y is 0. What else did they tell you to put down? A y-intercept, also incredibly easy. What do you do? Set x to be 0. And what do you get there? Well, 0, 0, minus 3. Then they told you to plot those points. Let me go over here and plot those 3 points in this graph over here. So 1, 0 right here. The other point is minus 3, 0 right over here. And the other point is going to be 0, minus 3. Now, depending on who your teachers were, it really depends in Math 100. Most teachers would probably say, well, there's symmetry here, that what you're doing is you're drawing a line between those 2 points, and that's going to help you draw the curve. So let me draw that line down. It's an axis of symmetry. And I know it's between those 2 points. It's a very primitive technique, by the way. And what's the equation there? X equals. Well, the dead center between 1 and minus 3, you add those two numbers together, you would get minus 2, divide by 2, you would get minus 1. Now that's the axis symmetry, AOS. We're just reviewing what you did in Math 100, by the way. And then what they say, the vertex must lie on the axis symmetry. So if the vertex lies on the axis symmetry, what do I know about the vertex? I know just one thing. I know the x is minus 1. Now, how do you figure the y out? I don't know. You got to plug it in, I guess. So what do you get over there? Y equals minus 1 squared is 1. Then 2 times minus 1 is minus 2, minus 3. And what do you get? Lo and behold, you get minus 4. Did I do that right? Yep, minus 4. Go over here, plot the point out. And after you plot those point out, they say, I hope it's obvious that you know what the picture looks like. And let me kind of draw the parabola now. And someone could say, well, the parabola is already there. Why do you need to draw it in? I'm just reviewing what you did in Math 100. All right. So then the teachers in Math 100 said, you know what? Sometimes it's really tough to get the x-intercepts because the function's not factorable. And if it's not factorable, doing this technique's probably not going to work out too well. Right. I will say this, though, the technique does work out well. So what they say is, what happens if you just get a general statement? I'll write this over here, and I'll go through the formula that your teachers gave you in Math 100. I'm hoping they When they gave it to you, they explain it to you, but sometimes they don't. Sometimes they give you things without justification. Not that there's anything wrong with that. Most students are not interested in the justification anyway, but I will say this, it's nice to know what the justification is. So they gave you a formula for vertex. I'll write this over here. And this y is a function of x. And they said the vertex is minus b over twice a, comma, f of minus b over twice a. And a lot of students say, okay, that's enough for me. I don't want to hear where that came from. They're going to use it, and they do use it. All right, so what I want to do is just reviewing Math 100. I'm going to go through this. And remember what we said about this thing. We're really looking for x-intercepts. How do you get the intercepts? You set the y to be 0. When you set y to be 0, what do you get? ax squared plus bx plus c. What do you get? X equals, I'm using the quadratic formula. Now, when you did quadratic formula in Math 100, they derived it by completing the square. And you can do that again if you want. This would be minus b plus or minus b squared minus 4ac over twice a. So I got two x-intercepts. And what are they going to be? Let's write this down. Minus b minus the root of b squared minus 4, whoops, sorry about that, 4ac over twice a. The y would be 0. That's one x-intercept. What's the other one going to be? Well, the other one's going to be, let's see, minus b plus b squared minus 4ac over 2a, comma, and the y would be 0. Again, they're x-intercepts. All right, so what do you do now? Add those 2 points together. And what's nice about that? Well, if you add them together, this is the only thing that should cause you a challenge over here. But what you get if you add together? You would get, minus 2b. Well, the radicals disappear over 2a, right? Then what do you have to do? Add them together and divide by 2. I'll do that in a second. And what's the other one? 0 plus 0, which is 0, divided by 2. This is the midpoint between the x-intercepts. So midpoint between the x-intercepts. By the way, that doesn't matter what the x-intercepts are. They could be real complex, whatever. So what's the midpoint going to be? It's fairly simple. It's going to be, let's see, minus b. I'm simplifying this, by the way, over twice a, comma 0. So 2 x-intercepts, I get the midpoint. What do I know about the midpoint? That's the axis of symmetry. So what's the axis of symmetry? The AOS for any given parabola, provided to put it in this form over here, is going to be x equals minus b over 2a. All right. How do you get the vertex? The vertex has to lie in the axis of symmetry. So what's it going to be? Minus b over 2a, f of minus b over 2a. And again, that's a justification that your teacher should have told you in Math 100. So there's nothing wrong with that. All right. So some of your teachers might say they didn't justify it. They just gave that to you. So we went through that example over there. And, you may have to review it. I don't know. I hope this is, like you're saying, this is really stuff I've done so long ago that it's almost trivial to me at this point. So what I got to get to is what they started doing in Math 120. They started to formally define what a parabola was. All right. And, we'll look at pictures over here, but I'm not going to derive these formulas. And the reason for that is it was already done for you. So what you may say to yourself, I don't remember, my teacher didn't do that. I was absent for weeks at a time, but the teacher was really nice. He understood all my troubles and he gave me an A anyway, but I didn't know any of the material. That's a problem. You got to go back and review. Now, where do you go back and review? And let me point this out to you. You want to go back to my course website. And what course website we're talking about? Well, I'm talking about going back to Math, mth. Well, you're in 122, right? What are you going back to? 120.mathography.org. All right, that's true for all my sites. For example, if you want to go back to 119, instead of 120, put 119 there. If you want to go back to 100, you go to 100. If you want to go to 121, you go to 121. If you want to go to 122, you go to 122. You get the idea. I think you get the idea. So what I'm claiming over here is that when you took Math 120, which is, it's certainly in recent memory, hopefully, Now, some people might say, oh, no, I didn't do it at Essex. I did it at this school. Well, any responsible school would have to do the same thing, by the way. And I'm going to say over here, I'm not trying to memorize things, but I want to point out, whoops, sorry about that. I got to go backwards. Give me a second. Oh, boy, I really screwed up here. Let me just get rid of this thing here. All right, I got to go backwards again. This always happens to me. I'll tell you, I don't know why. All right, give me a second here. All right, sorry about that. I got to get my highlighter out. So I'm going to, I will go through this. And when I go through this, what I'm going to claim is I'm not trying to memorize anything. I'm just saying that these are our standard forms over here. All right, there are standard forms. Right. What else did you do? Well, going back to Math 100, you also did circle. Let's go to the next page, and I'll kind of remind you what we're doing over here. All right. So the claim about this standard form, that's just a review. I'm going to write this on the side for you. What are we going to get? We get x minus 1 squared. If we can write in this form, this is what's called standard form. 4 times 2. I'll remind you what these letters mean over here. We'd like to write it over here. All right, so what I'm going to do over here is I'm going to get what's called the vertex from the standard form. All right, it's going to be, yeah, I'm just looking at it. It's going to be x will be 1 and y would be minus 3. Let me point this out to you. That makes that 0. That makes that 0. All right, you see that? All right, let's go over here. I'm going to plot that point. What's that point? 1 minus 3. Okay. The other thing we get from this form, which is standard form, we get what's called the P number. This is the P number over here. So the P is 2. When it's in this form and P is a positive number, which this is, this means it's going to open up. And what's the P? The P is the distance in from the vertex to the focus. So I'm going to be able to put the focus down now. This over here is the focus. Let me get back to red ink. This over here is the focus. What did I say it is? It's 2 units in from the vertex. So the vertex is going to be 1. Now you're at minus 3. If you go 2 units in, you're at minus 1. Now someone says you gave really nice pictures. I could have just read that from the picture. I'm not denying you can't, right? And then what do we get? We get a directrix over here. That's 2 units away from the vertex. Well, that's going to be an equation of a line. And what's that going to be? Y equals, this is directrix. And what is it going to be? Y equals, let's see, I'm going to 2 units down from minus 3, so that'll be minus 5. Now, someone says, you gave me a really good picture. I could have gotten that. All right. Do we have an axis symmetry here? We do. I'll draw that in for you. And then what do you get over there? Well, it looks like it's going to be x equals, right? This is an axis of symmetry, and that's x equals, well, it looks like looking at it, goes right to the vertex, x is 1. All right. Let's talk about the derivation now. Why do we like this form? It's a derived form. This is derived. How's it derived? It's derived from the definition. Again, I'm not going to go through that, but I want to point out what the definition says for a parabola. It says a set of points such that the distance from the focus to a point on the parabola and that point in the parabola to the directrix will be identical. All right. Now let's do another one. Like let's say you did this one over here. This distance here is identical to this distance here. And again, this is where the derivation came from. Let's say you did this one over here. This distance there would be identical to this over there. So when your teachers taught math 120, what they did was they derived the equation of a parabola, right? And they did it for one that was centered, so the vertex at the origin, and then they just translated it around. Super simple, all right? So for parabola. So I'm going to put the next one down, and I'm going to write this one over here. It's a parabola. I'll write the equation down for you, and the equation is going to be y plus 2 squared equals 4 times 2 x minus 3. Well, this is standard form. So when am I going to put the vertex down? And it's easy. It's really easy once in standard form. What's the x? The x would have to be 3. What's the y? The y would be minus 2. I'm going to go over here and plot that point for you. So 3 minus 2, right? Someone says, you gave me a really good picture. Why do I need to do that? Well, we're just learning, right? We're just, I should say just, we're reviewing what you've done in the past. Now, what I want to do is talk about the p in the problem. So what's the p in the problem? The p here, it's still 2. Is that a positive number? Yes. But I want to point out, this is not an x squared problem. This is a y squared problem. So in this case over here, our parabola opened like this. So what does the p tell me? It tells me how to get to the focus. What's the focus going to be? 2 units to the right of that vertex. So what do we get over here? It's this point over here. What's 2 units to the right? Let's write this over here. 3. Not 3, it's 2 units to the right of 3, isn't it? What's 2 units to the right of 3? 5. The y did not change, minus 2. Put that point down for you. What's this over here? A focus. All right. I'm going to say you should also put the directrix down. And what is that going to be? 2 units to the left. So what's the directrix? Well, that's going to be x equals, let's put it in black. X equals, I'm sorry, I said black, I'm still in red. X equals, well, I'm going to go 2 units to the left of 3, which would be 1, right? Now someone says, you drew a picture, I see that anyway. Well, a lot of times you're not going to be given a picture. And then I can think I could draw my parabola, and I'm never quite good at this, but I'm going to say maybe something like this over here. All right, axis symmetry, put that in for you. What's that going to be? This is the AOS. And the axis symmetry looks like y equals, it goes to the vertex, right? So that'd be y equals minus 2. All right. All right. I'm going to say, yeah, it's enough review of parabolas. We'll do more certainly when we get to the examples. But right now, we're just kind of jogging your memory what you did in Math 120. Let's take a look at this one. This is clearly a circle. So I'm going to write it down for you, and we'll go through that standard form. Circles you did in Math 100. They were reinforced in Math 120 and in Math 119. They're simplest objects you can come up with for a conic section, easy to understand, and they're really nice. What do you get up here? I'm going to put in standard form. I want to tell you what the standard form is. It's going to be x minus h squared plus y minus k squared equals r squared, with the understanding that the center is h comma k and the radius is r. Let's try to get in standard form, and then we'll look at the graph and reaffirm our beliefs that we know how to do this. So x squared minus 2x, getting the x together, then the y's together. Get the number on the other side. It sort of looks right. Now complete the square. Half of minus 2 is minus 1. Square it, you get 1. Add 1 to both sides. Half of 2 is 1. Square it, you get 1. Add 1 to both sides. And what do you get? You get your standard form, which is x minus 1 squared plus y plus 1 squared equals 4. What's the center? 1 minus 1. We'll look at the picture later. And the radius is actually 2. Let's go over here and let's look at it, see how we did. All right. So again, someone says you did the picture. I wouldn't need to do that if you give me a picture. Your goal is to get a picture. What's this point over here? It's the center. What's the center? 1 minus 1. When you took Math 100, the teachers recommended that you just move up, down, left, right from the center point. Why is that? The points become very easy to do if you know the radius. What's the radius? The radius is 2. Well, if you're at -1, which is the y coordinate, and you go up 2, what number would you be at? 1. I clearly see that. If you're at -1, which is the y coordinate, and you go down 2, you'd be at -3. I clearly see it in the picture. Let's do these points, which is moving left and right. Well, the y is not changing in both cases. What's changing? The x is changing. So if you're at 1, you move 2 to the right, you'd be at 3. If you're at 1, that's the x coordinate, and you move to the left 2 units, you'll be at -1. Then what the teachers tell you to do, try to do the best job possible of drawing a circle through those 4 points. All right. All right. So I'm going to say, for the most part, fairly simple. Both parabolas and circles are fairly simple. Parabolas and circles were done in Math 100. However, when you got to Math 119 and 120, they started talking about parabolas in a slightly different way. Particularly in Math 120, they talked about a definition of a parabola as being a set of points meeting a condition. And that was the loci problem we did in Math 120. All right, so the next thing up is the ellipse. And certainly, I know there's a lot of information over here. Someone says it's so much, I'm overwhelmed. Well, it's just a review. So I'm going to go to the next page. And I'm going to look at an example, and I'm going to go through it with you. I see the picture, and I'm thankful for the picture because it's going to allow me to talk about some features on it. I'm going to remind you what your teachers did in Math 120, though, to do this problem over here. This was not done in Math 119, and it was not done in 100. It was done in Math 120. So I'm going to remind you, and I'm going to put this down. So it's 4x squared. 4x, let me go back to black ink. Sorry about that. 4x squared minus 8x. I'm just rewriting the equation, by the way, plus y squared plus 4y. Again, I'm hoping your memories are coming back. What I would do is I want to complete the square, but the way I put squares, I want a coefficient of 1 to be on the term, the x squared term. So it's going to be x squared, I'm factoring a 4 out, minus 2x plus y squared plus 4y equals 8. Going to complete the square. Half of -2 is -1. Square it, get +1. Now I know from past experience, a lot of students make a mistake now. They think they're adding 1. You're not adding 1. You're actually adding 4. All right. We'll go to it in a second. Half of 4 is 2. When you square 2, you get 4. So I'm adding 4. I'm actually adding another 4. Let's write this down. So you get 4x minus 1 squared plus y plus 2 squared equals, let's see, 8. Oh, 16. That was easy. Then what did the teacher recommend you do? The teacher recommended that you divide both sides by 16. Main reason it makes the thing so much easier to deal with. And what do you get? X minus 1 squared over 4 plus y plus 2 squared over 16 is equal to 1. The number one reason they did this is to make it easy. So I'm going to look for easy points. Give me 1 second. I'm going to say one easy value would be to select the x to be 1. All right. Why is that? This disappears. So what do you get over here? Well, y could be 2, right? I'm going to write that down. Now, if x is 1, y could also be -6. Let me repeat why that is. If I pick 1 here, this becomes 0. If this is 2, 2 plus 2 is 4. 4 squared is 16. 16 divided by 16 is 1. If I pick 1, this would become 0. -6, -6 plus 2 is -4. -4 squared is 16. 16 by 16 is 1. All right, there's more easy ones. Let's keep on going with easy. What I'm going to pick now is -2 for y. And this is exactly what your teachers should have done in Math 120. So if you pick -2, what disappears? The second term. So I left off with x minus 1 squared over 4 equals 1. So I'm going to say a nice easy point would be 3. I'll go through that a little bit later, and minus 1. Let me point. So if I chose 3, right? 3 minus 1 is 2. 2 squared is 4. 4 divided by 4 is 1. If this minus 2 this disappears, and 1 certainly equals 1. Let's try the minus 1. Minus 1 minus 1 is minus 2. Minus 2 squared is 4. 4 divided by 4 is 1. And again, if minus 2 is over here, it's to 0. So it works out beautifully. So how many points do I have? 4 easy points. 4 easy points. Whoops, sorry about that. So what I want to do is I want to look at the graph, and I want to see if I can recognize those 4 easy points on the graph, right? So let's take a look. And I'm going to look at it. Give me 1 second. And I'm going to do 1 point at a time looking at it. I'm looking at 1, 2. By the way, for students that have a hard time seeing, you can blow these graphs up with your finger. 1 minus 6. All right, what's the other point I see? 3 minus 2. What's the other point I see? Minus 1 minus 2. I hope you realize you're seeing 4 characteristic points on that. The other thing I can get from my standard form, I can get what's called a center point. So I'm going to write that down for you, the center. Well, just like we did for circles, it should be relatively simple to do. When does this become 0? At 1. When does this become 0? At minus 2. I'm going to go back to the picture. And I want to make sure you know that point is there. What point we're looking at? 1 minus 2. All right. There's 2 more points there. Before I do that, though, I want to claim there's a major axis and a minor one. The major axis is going to be the one that's the longest distance. Sometimes that's really tough to know unless you're looking at a picture. And I'm going to recommend that. So I definitely see the longest axis there. And I'm going to say there's 2 additional points over here. Now in Math 120, the formula was derived for this. But what I'm going to claim over here is most people had a tough time deriving the formula. But if you go back to Math 120, my notes, you would see it being derived in my notes. All right. You'd also probably see a little video over there. And again, you could rewatch lectures if you have to. But what is it going to be? The c squared. I want to point out what I mean by this. The c is going to be the distance in from the center to the foci. How many foci are there? There's 2 of them. But then the question is, how do I get the c? Well, it's really the c squared I'm looking for. And what's it going to be? I'm going to emphasize what this is. It's the difference between these 2 numbers over here. Well, what's the difference between 4 and 16 is 12. So what's the c going to be equal to? Well, I know it's plus or minus, but I'm just going to take it to be a positive. I'm going to distance in. Root 12. If you prefer, you could write this as 4 times 3, which is 2 root 3. All right, I'm going to talk about foci 1. And that's a point. Now, what do I know about that point? Let me blow this up for you. That point is definitely 1. What's this point over here? I'll call it foci 2. It's still going to be 1. Here comes my problem. I need to move in from the center. So it's going to be minus 2, minus 2. This one's going to be plus. This is going to be minus. I'm going to back off from it. So how much am I moving in? 2 root 3. Done. We're completely done with the picture. So I want to point out answers are listed for you, yada, 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 yada. All right. All the answers are listed for you. So also I want to emphasize in Math 120, what your teachers probably did was to find these words over here. Okay. I want to tell you something about my own life. A lot of times when I'm reading things, I can't remember things. All right. I just can't remember. I know the word. I've seen the word. I can't remember the word. So what do I need to do? I need to look it up. you should feel no shame in having to look things up, including in mathematics. You can't remember something, look it up. The more you interact with it, the more likely it is you'll be able to remember these terms over here. Here's the deal though. You're going to be reading a newspaper. Typically, they're going to talk about these words over here. If you see those words, you might have to look them up. All right. I don't find it terribly important for this topic, but nonetheless, if you have a textbook and you're reading about it, you'll see these words being mentioned with respect to this ellipse that we just drew. Let's go to the next page. And I want to point out, you also did hyperbola. All right. They talk about different forms of them, but for the most part, I'm not going to worry about the forms. What I'm going to worry about is when I see something like this, getting it into one of those forms, not memorizing it, but getting it into the form. So I'm going to write this down for you. And just like I did before, I'm going to write it down. So 9, let me go back to black. 9x squared minus 18x minus 4y squared minus 16y equals 43. But what I'm going to do is I want to complete the square like I've always done in the past. So I'm going to factor out a 9 because I want the coefficient on the square term to be a 1. I want to be honest with you, for the most part, they make these problems very simple. And I'll tell you why. They want to make sure you can do this without too much arithmetic struggle. What are you going to factor out now? A minus 4. What do you get? Y squared plus 4y equals 43. All right. By the way, if I've ever do something and make a mistake, pretty much another mistake if things get really, really difficult. All right. Now that varies from student to student, but this should not be becoming difficult now. What am I going to do now? Half of minus 2, which is minus 1 squared, get plus 1. We did not add 9. I'm sorry, we did not add 1. We added 9. Now what goes over here? Half of 4 is 2 squared, you get plus 4. We did not add 4. We subtracted 16. Let me write this down for you now. What do you get? 9 x minus 1 squared minus 4 y plus 2 squared equals, let's take a look. It's tough though. I'm not saying it's easy. I guess it's 36, right? Let's see, 49, 43, 52. Yeah, 36, not bad. What am I going to do now? Divide both sides by 36. That's what your teacher told you to do. And the reason for that is it makes it easier to deal with. What do you get over here? X minus 1 squared over 4 minus y plus 2 squared over 30. I'm sorry, not 36. 4 into 36 is 9, right? Equals 1. Again, the only reason they did this is to make it easy. That's the only reason. I'm going to look for an easy point. The way to do that, I would select y to be minus 2. Someone says, why are you doing that? To make this disappear. What would you left off? X minus 1 squared over 4 would have to equal 1. Well, what number would give that? There's actually 2 numbers that would do that. One of the numbers is minus 1, and the other number would be 3. Let me go through that with you. Minus 1 is minus 2. Square, it's 4. 4 divided by 4 is 1. Minus 2 over here makes it disappear. Of course, you get the 1. Let's try the 3. 3 minus 1 is 2. 2 squared is 4. 4 divided by 4 is 1. Minus, well, if it's minus 2, this would be 0. You get the 1. These are 2 easy points. So someone's going to say, big deal. I got easy points. I would recommend that you graph those easy points. All right. Let me go through that with you. And we're looking at a good picture. Sorry about that. I made a mistake already. So what I say, minus 1, minus 2. And the other one was 3 minus 2. I realize someone says, I have no idea where this is going. So we got to keep moving. I got 2 lousy points. So what are the other points I want to look at? Some people say, you know what? Why don't I do this too? Why don't I make x to be 1? Well, if you did, this would become 0, and you would find no real solution to that problem then. So I wouldn't do that. What I could do is I could write the center down now. Well, just like other conic sections, I'm just doing the zeros of those terms. So 1 and minus 2. Let's go back over there. And I'm going to try to do that. That's 1 minus 2, right? Again, if you need to blow these graphs up, blow them up with your fingers. All right. They're really simple. All right. So someone says, what else could I get from this? And what I want to claim over here is that I would like to get the asymptotes next. All right. So someone says, how do you do asymptotes? Well, what I do is I let x and y go towards plus or minus infinity. Now, if I do that, I want to point out they're always going to differ by 1, the two terms, when x and y goes to infinity. But as you go towards infinity, these terms get hugely large, but they always differ by 1. But if you're hugely large and you're different by 1, you're what's said to be equal. So all I do is set them to equal one another. So y plus 2 squared over 9, when x and y gets large, look identical, asymptotically the same. What do I do now? Well, I'll write this down. It's y plus 2 squared. We're looking for asymptotes, by the way. 9/4 x minus 1 squared. What do I do now? Square root rule. What do you get? Y plus 2 equals plus or minus 3 over 2 x minus 1. There's two asymptotes now. They're linear asymptotes. What's it going to be? Y plus 2 equals 3/2 x minus 1, and y plus 2 minus 3/2 x minus 1. I'm actually going to draw those in for you. And someone says, how could you draw them in? I see the picture. All right, so I'm going to put this over here, and I'm going to draw those asymptotes in. Yeah, you have to be able to draw a line, by the way, and they go on forever. All right, what am I saying? I'm saying that this curve has to be asymptotic with that. Fairly simple. As we go towards plus or minus infinity, by the way. All right, there's 2 more points I'm noticing. And I'll put this point over here. I don't know what it is, but I'm going to call it a focus 1, and this point over here, and I'll call it focus 2. Now, what do I know about the focus? Kind of looking at it, I know what's on the inside of that curve. And what do I know about it? I definitely know the y is minus 2. I definitely know the y is minus 2. What I don't know is the x. However, something says, you know what? I'm going to read it from the graph. And the problem for that is maybe you can't read it. Maybe you look at this and saying, well, I'm looking at this thing. I don't know. Maybe it looks pretty close to 5, right? You might say, hey, maybe it's a bad picture. Maybe it's just 5. Not a good idea. So we need to go back to what you did in math 120. You derive the formula for this object by its definition. All right. And again, if you want to, you can go back and review that. Whoops, sorry about that. I'm really screwing up here. And I'll tell you what it is. So we have this form over here. Whoops, sorry about that. And what it is, it's the sum of these two numbers would be the c squared now. It's the sum of those two numbers. So it's going to be 4 plus 9 is going to be the c squared. So what's the c going to be? Root 13n. Let's talk about this. We're here and we're moving in root 13. So it's going to be 1 plus root 13n. And what goes over here? 1 minus root 13. All right, let me go to the next page. And I want to point out all the work is down there for you. All the work is down there for you. What I mean by that, the answers and all that work is down over there. All right, so, they talk about asymptotes. Let's see how we're doing. Yeah, they do another picture. Let's see. You know what? We didn't do this one. Let's do this one now. All right, we'll do all the points. And by the way, somebody says, why do you give me pictures? We give you pictures for a reason. We want to have accurately drawn pictures so you're not like looking at my chicken scratch. All right, let's write this down. And I'll be very careful. factoring a 9 out. The reason is I want the coefficient on the square term to be 1. 9 times 6 is 54, right? Minus, I want the coefficient of the x squared to be 1. Let's see what we get there. X squared, right? Minus 8. Mistakes can happen. Equals 19. Got to complete the square, right? Half of 6 is 3. I have to square 9. That's plus 81. Half of 8, minus 8 is minus 4. Square it, gets 16. I'm subtracting 64. All right, let's write this down. 9 y plus 3 squared minus 4 x minus 4 squared equals, let's take a look at that. That'd be 36, right? Boy, this is deja vu. So what says, why is it deja vu? We tend to use numbers that are quite simple. Divide both sides by 36. What do you get? Y plus 3 squared over 4 minus x minus 4 squared over 9 equals 1. I could do some really easy points over here. I want to point the easiest point I could pick is when x is 4. These are what's known as the vertices, by the way. And again, we'll go with more examples later. So what'd you get over there? Well, I guess you'd get, let's see, what would you get? I guess minus 1 would be one of them. Because minus 1 plus 3 is 2, and 2 squared is 4. That looks pretty good. What would the other one be? I guess minus 5. And minus 5 plus 3 is minus 2. When you square that, you get 4. So let's put those 2 points down. And again, we're trying to jog your memory. 4 minus 1. That's a vertice. 4 minus 5. That's a vertice. I could also write down the center, looking at it. What's it going to be? The center is going to be 4, comma, minus 3. Let me plot that for you. I could do the asymptotes pretty easy. I'll write that down for you. What are the asymptotes? When x and y are going to plus or minus infinity. What are we saying? They differ by 1, but when you go towards infinity, differing by 1 is incidental. We say they're equal, asymptotically anyway. Square root rule, plus or minus 2/3, x minus 4. I'm going to write that down for you now. This line over here is y plus 3 equals 2/3. It's a positive slope, x minus 4. What's this line over here? Y plus 3. It's a negative slope, minus 2/3, x minus 4. All right. Foci. Let's do that. Relatively simple. What do we do? We're adding these two numbers now. That's going to be 13. That's c squared. So what's c? C is root 13. So what I got to do? I got it from the center. I have to move in root 13. And that's pretty easy to do, by the way. This is the foci. This is a foci over here. I'll call it foci 1, foci 2. And what do we know? I know the x value is 4 in both cases. It's the y value that some students struggle with. We need to move in from the center, right? So it's going to be minus 3 plus root 13 when we go up, right? And what's this one over here going to be? Minus 3 minus root 13 when we go down. All right. So let's just, make sure you know that the answers are listed for if you want to take a look at that. The thing is, there's this optional material over here. I'm not going to do it. And the reason for that is it's overwhelming. It's something you've done in the past. It's difficult. I do want to claim, though, it can't hurt to reread that stuff and jog your memory. I'm not saying it's nightmarish if you go through the derivations, although in Math 120, we went through the derivations of this formula here and this form over here. And we use those to rotate. When do we know to rotate? When we get a problem where we have a term like this in it. If you have a term like this in your problem, you're going to need to rotate it to get to a new coordinate system. We rotate it to an acute angle. That means an angle between 0 and 90 degrees counterclockwise. All right. So there's examples over here. If you want to take a look through that, it's optional. What does that mean? I'm not going to retest you on that. It's kind of tedious, but it's something you should be able to do and realize that you get some nice little pictures over here of rotating a conic section. Okay, let's go to the examples next. We're done with the lecture. The lecture was largely a review of what you've done in Math 100, 119, and 120.